All right, wonderful. Thanks. So last but certainly not least, before we head to the panel session, I do want to make sure that people leave on time if they need to, and we're perfectly on time. So thank you everybody for respecting that. Really appreciate it. So last up, Delta Project. Speaking for the Delta Project will be Apostolos Tsolakis, hopefully I pronounced that correctly, from the Center for Research and Technology in Hellas. Take it away, sir.
Thank you very much. Good afternoon to everybody. I'm Apostolos Tsolakis, and I will be presenting Delta. I'll try to be brief. Delta is a research and innovation action which lasts for 3 years. We are currently on our third year. The budget is a little bit lower than 4 million, 10 partners from 8 countries for the consortium, and we have an aggregator from UK and a DSO from Cyprus. I will not go too deep into the rationale and the motivation. The idea is to untap the flexibility through demand response services, just like other projects in this afternoon session. However, our focus is to present a different distribution structure that focuses on small and medium customers through a novel, secure demand response management platform. In order to deliver that, we wanted to ease the computational effort of the aggregators, which is the main focus of our project, by distributing the intelligence required for DR response, demand response at the energy markets. Also, we try to engage prosumers with added value services that have to do with collaboration, incentivization, and gamification. And we try to promote interoperability by adopting the OpenADR standard for all communications through one of the ontologies that we have developed based on the OpenADR standards. And of course, as discussed before, we have some new business models and recommendation for policymakers in order to be able to adopt these services that we are delivering into the markets as soon as possible. Here you can see our concept in a graphic representation. So instead of the centralized approach that's currently in the smart grid, where the aggregators have access to each customer specifically, we are trying to relieve aggregators from these resource-intensive tasks by introducing the Delta virtual node and the fog-enabled intelligent device at customer side. So we explore the virtual power plants principles in order to present to the aggregator large entities that can participate to the energy market as they are right now, but aggregating small and medium customers together to be able to present that without needing the aggregator to handle each customer one by one. Of course, we are also trying to simplify and fortify the contractual agreements, not only by providing enhanced security through the Delta blockchain, but also with smart contracts. So every transaction is automated through a smart contract over the Delta blockchain. And of course, we have other key enablers like the collaboration platform, the award-enabled services, and enhanced visualization aspects for the customers. The impact that the project has mainly focused on interconnecting the energy stakeholders at all layers to provide stable and secure increase of renewable energy source penetration by better handling all assets regardless of their size. Affect ongoing policy developments either at standardization bodies or at EU and national policy making. Bring greater energy security, sustainability, and competitiveness by new services and new business model. And the most important thing is to provide access to modem, specifically small prosumers. We have 3 pilot sites, 1 small pre-pilot at Greece and 2 large pilot sites at UK and University of Cyprus. And we divide our work in 3 layers, starting with a Delta customer, which is the most important aspect. We have designed a hybrid device, both in terms of hardware and software, which is a novel, powerful toolkit that empowers small and medium customers to participate in TR programs. We have enhanced security with an embedded DPM module. We have direct communication with various wired and wireless protocols, and of course interfaces for smart meters, building and energy management systems. And of course, as said, we are OpenADR compliant. You can see here the new device. On this device, we are running a series of lightweight software engines, starting with load and PV forecasting. We also have a new approach for flexibility estimation. We combine unsupervised and supervised models in order to be able to extract the flexibility potential of a customer from a central point of measurement without getting into more detail on asset level. And of course, by having all of that information, we are able to deploy and optimize self-consumption logic that combines all available assets without the aggregator having knowledge over it, and of course, maximizing both financial and comfort objectives from the customer side. Getting all of that information reported to a higher level, a virtual node that follows the virtual power plant principles. We have a multi-agent framework that provides a highly robust ER management. There's an internal clustering feature that uses flexibility, availability, reliability, and other metrics in order to efficiently find the most appropriate customers to handle a DR request from higher levels. We perform a cross-validation on all forecasting through individual and aggregated results. So we get the individual results, and based on other algorithms that are executed in aggregated level, we are cross-validating the results. So we can report to the aggregator a result that is as close as possible to the actual thing. And of course, we have an intelligent optimal dispatch and fail-safe mechanism to ensure DR success within each virtual node. This is quite interesting because, first of all, we introduce flexibility as a virtual distributed energy resource. So imagine all optimization schemes that are applied on DERs that can use now flexibility as one of them. So we use that to test the various optimization schemes for DERs in the literature. And also we introduced two fail-safe mechanisms, one intra and one inter-DVN communication in real-time operations, so that we can identify when a DR is going to fail because one of the customers cannot deliver what has been requested. We quickly find other customers that have the flexibility and are available at that time to deliver that amount with explicit DR requests, in order to get that either within the same node or to other nodes that fill in certain constraints. Going to the last layer, which is the aggregator, we try to keep the role of the aggregator as it is right now with added value services. We have an efficient, automated, and dynamic aggregation of small and medium customers. We practically create the DVNs and we adapt them over time based on historical data as well as contractual data. As you can imagine, we can handle also large customers as is, because one DVN is assigned to one customer, and this facilitates things because we don't have to run two engines at the same time. We have two engines for price forecasting, which we have developed and we are trying. We have the intraday and the imbalance markets, based on which we are trying to bid and identify how we can maximize the aggregator's revenue. We have an unobtrusive collaboration with DSOs for ensuring grid stability. So we have a grid topology which runs on an external simulation platform when we execute different scenarios every time we have a DR request to see whether it can be a threat to the stability of the grid. We also have a dynamic optimization based on spatio-temporal characteristics, DVN reliability, and fairness. And finally, on the aggregators level, we apply the gamification collaboration services in order to maximize end-user engagement and DR success again. So we have demand response games, we have collaboration games, we have identified vouchers that can be given based on the points that they have earned from the gamification process in order to keep the prosumers active, because we have to gain as much as possible from their flexibility. As horizontal services, we have the Delta permission blockchain. It is based on hardware ledger fabric, and all information that is related to demand response is stored on the blockchain. And also we have the smart contracts On top of that, which have integrated all OpenADR services in order to be able to handle automatically all transactions. So as soon as a DR request is serviced to either of the layers, a smart contract is created, and either if it is rejected or failed or successful, everything is handled automatically by the engine on the back end. So as you can see, I tried to make it as brief as possible to give more time for questions. Delta envisions to harness the untapped potential of small and medium customers by providing a framework that can automate, but also secure and to make more efficient demand response management, while also creating added value services that can enrich the experience for the end users, raising their engagement and providing, let's say, more interesting approaches for them to actually participate in NDR requests. And through all of that, we introduce new business models and revenue streams for all involved stakeholders, starting not only from the aggregator, but also from higher levels up to the small customer. In particular, our business models will be present and will be introduced in one of our webinars, where we expect to have, where we will have speakers from both EU and US stakeholders, and we will be presenting market perspective and business opportunities for demand response in Europe. It's on the 19th of November, and we would like to see you all there to continue the discussion over the business opportunities of demand response. I hope it was brief to give more time for discussion. Thank you all, and if you have any questions, I would be delighted to answer them.
Zia, are you talking? Maybe you are unmuted. I'm not hearing you very well. Zia will take the lead to make the conclusion in a minute.
Okay, well, maybe, I guess, luckily we had the technical difficulties at the end, but maybe we could say goodbye unless there are any final questions, but I don't see any in the chat box.
No, I see neither no new question. Zia wanted to make some conclusion and ask all the panelists if you have some conclusion and new ideas on topic, but yeah, as the time is running and as you have that technical issue, if nobody have something to add.
No, thanks.
Hello?
Okay, yes, yeah, you're
Okay, sorry about that. I lost my sound. I apologize, everybody. Thank you, Apostolos. There is one question, or maybe two questions. Let's see here. Okay. Oh, several questions. Let's see. No. Okay. What is the main benefits of open ADR according to you? And that's for Apostolos.
Well, to start with, we have a formal way of actually translating the information required for demand response signals. And through the Delta framework, we actually created the OpenADR ontology in order to also support semantic interoperability. So we took the standard, we created the ontology, and we are now practically using both with main focus on the ontology part in order to be able to handle more efficiently the, let's say, machine-to-machine information exchange within the framework, and of course with third party. As you know, I don't know if you're referring to the OpenADR specifically or to common frameworks and standards for exchanging information. However, there is quite a limitation in terms of standards for demand response. Even OpenADR has some let's say, limitations that we are currently trying to identify and present with our communication with the Alliance. We know that they are also working in order to present merits and a new framework as well. So towards interoperable systems, it is good to work on one framework which should be adopted by everybody in order to facilitate things instead of working with a lot of different protocols.
Okay, thank you. My webcam doesn't seem to be working, and I think that instead of having a panel, I think we might as well just close here, and then we can follow up. So there'll be a post-workshop survey for the attendees who will receive it via email. And we hope that you answer that and look more into the projects that have participated today. We appreciate everyone's support of the conference and of this workshop. We hope you enjoyed it, and I think we'll close here. So thank you, everybody, and have a wonderful evening, and enjoy the last day of the conference tomorrow.
Thank you. Bye.
Good night.
Bye.
Thanks
Thanks,
so much.
everyone.
Thank you all.
Very much.
Thank you. Goodbye.
Thank you. Bye-bye.